Alright, so when you're working a math section on the SAT, they'll always throw one of these really tough questions in at the end just to test you. And really they're only that difficult because they require either a couple extra steps or a different way of thinking about it. But if you know just a little bit about what you're doing, or you can figure out one or two little things in the problem, they actually are not that hard to do. So I'm going to show you how to solve this problem. This is one of the more difficult problems that they'll throw in at the end of a math section. If the circle with a center O has an area 9 pi, what is the area of equilateral triangle ABC? One of the most frustrating things that my students tell me is, I don't know the formula for the area of a circle, or I don't know the formula for the area of a triangle. And the reason that's frustrating is because they give you those formulas at the beginning of every section. Here's a snapshot of the little formula box, or whatever you want to call it, that's at the beginning of every math section on the SAT. So you can grab the formulas you need from here. And the two we need for this problem are going to be the area of a circle right here, and it's kind of tiny, it's kind of hard to see, and also the area of a triangle, which is this one here. So if the area of the circle is 9 pi, the formula for the area of a circle is pi r squared equals 9 pi. So if you divide both sides by pi, those cancel, and you're left with r squared equals 9. If you take the square root of both sides, you get r equals 3. So the radius of this circle is 3. That means the diameter of the circle is 6, which is the distance from here to here. That's 6. That's also the height of that triangle. Remember, the area of a triangle is half the base times the height. And we have the height now, which is 6. So now we can use the Pythagorean theorem to find one of the sides of this triangle. But that's going to give you a bunch of numbers that you're not going to want to deal with. So if we go back to that little formula block that they give you, you'll notice over here you've got some special right triangles. And when you draw this line straight down the center here of the triangle, since the triangle is equilateral, you've cut this angle here in half. An equilateral triangle has 3 angles that are all 60 degrees. Since you cut this one in half, this angle here is 30. And since this is 90, that makes this a 30, 60, 90 triangle, which is this one here. So the side across from the 60 degree angle, this is the 60 degree angle here. This is the side across from it, is x on the square root of 3. Whereas this side would be x. I hope I'm making sense so far. So I'm going to run back through that last little part one more time. Since you cut this angle here in half, since this is an equilateral triangle, you cut this one in half, this is a 30 degree angle. And this is a 60 degree angle. So this is a 30, 60, 90 triangle. For any for any 30, 60, 90 triangle, where this small one here is the 30-degree angle. Here's the 90. That one's the 60. The side across from the 30-degree angle, it equals x. This side equals x times the square root of 3. And this side equals 2x. So this diagonal here is equal to 12. But that doesn't really help us here. We need this base. But we know this side is equal to x, where 6 equals x times the square root of 3. And this side is half of the base, which is we've already got in the equation. And we know the height already equals 6. So if we stick x times the square root of 3, and we stick that 6 in here, we can solve for x, which will give us that side, which gives us this. So you divide by square root of 3, so x equals 6 divided by the square root of 3. And half the base, so 6 divided by the square root of 3 is half the base. So half the base times the height. 6 divided by the square root of 6 divided by the square root of 3 times 6, the height, equals 36 divided by the square root of 3. So you can do a couple of different things from here. You can start punching numbers in the calculator and figure out which one of these equals this. Or you can use a little trick that we use to get the radicals out of the denominator. I say off of the bottom of it, but out of the denominator. So what we do is we multiply by square root of 3 over square root of 3. And the reason we do that is because square root of 3 times square root of 3 will just equal 3. So we'll get rid of the square root in the bottom. And also, square root of 3 divided by square root of 3 is just 1. And anything times 1 is itself. So we're not changing the answer at all. It's actually the same thing, but we're just getting that square root out of the denominator. So you end up with 36 times the square root of 3 over 3. And then 36 divided by 3 equals 12. So you have 12 times the square root of 3. Your answer is C. Alright, so that still might seem pretty complicated. So I'm going to take you back for just a second to this point right here when all we knew was this was 6. So remember, for our 30, 60, 90 triangle, if this side's x, this side's 2x, and this side is x times the square root of 3. Put this up here because when it was down here it probably got blocked out by that little logo. So I'll show you this again up here. Excuse me. So remember, this was 12 and this side is 6 divided by the square root of 3. Alright, right here. It's probably going to be easiest from right here to use the formula for the area of a triangle. Half the base times the height. Here's half the base and here's the height. multiply them together. Remember, we got 36 divided by the square root of 3 here. If you were a little confused by that stuff I did where I multiplied by the square root of 3 over the square root of 3, then go ahead and stick this in your calculator. And you'll get something like 20.784 blah blah blah, and it keeps going. So then just start plugging these in, and you'll find that 12 times the square root of 3 equals 20.784. It's the same exact thing as 36 divided by the square root of 3. Now obviously you're going to have to do that a whole lot quicker than I did, or you're going to run out of time. You're going to spend all your time on one question. But I did stop and go back over the same thing a few times. So once you understand that, you'll be able to do that a lot quicker than I just did. And also, these are at the end. These are the harder ones. You should be working on all the easy problems first. And you shouldn't even be working on these unless you have some extra time. So hopefully you've blazed through all the easy ones and you have a little extra time and you can work on this one.